In this video, I am going to explain about surface chemistry synopsis and worksheet questions. It's an important chapter. So first we will discuss synopsis, lesson structure. So your main points are, main subtopics are colloidal solutions, emulsions and catalysis. Next. So your first topic is adsorption. So accumulation or concentration of substance on the surface of solid or liquid is known as adsorption. Very, very important. So adsorption is only surface phenomenon. So adsorption can be divided into two types, physical and chemical adsorption. Next, physical adsorption is weak due to weak van der Waals force. Enthalpy of physical adsorption is low, 20 to 40 kilojoules per mole. So enthalpy of adsorption means amount of energy released during adsorption. Next, physical adsorption is reversible and very fast. Next, activation energy of physical adsorption is very, very low. Next, chemical adsorption is strong due to chemical bonds, chemical bond formation between adsorbate and adsorbent. Next, enthalpy of chemical adsorption is very high, 80 to 240, or you can take 80 to 400 also you can take. Chemical adsorption is irreversible and slow. Next, activation energy is very high. Next, the material on which surface the adsorption takes place is known as adsorbent. Next, the substance which accumulates on the surface is known as adsorbent. That means in case of adsorption, we will be having these two, adsorbent and adsorbate. So adsorbent can be solid or liquid. Adsorbate may be gas or solute from solution. Next. So critical temperature increases, adsorption of gas also increases. As the critical temperature increases, liquefaction also increases. So SO2 is adsorbed more readily than CH4 due to more value of critical temperature. Next, easily liquefiable gases are adsorbed readily on solids. That means on the surface of adsorbent. Next. Adsorption process delta H, change in enthalpy is negative, that means exothermic process. Delta S is negative, entropy decreases during adsorption. Very, very important. Next, the process in which both adsorption and absorption takes place is known as sorption. Sorption is involving both absorption and adsorption. Very, very important. Next, process of removing adsorbed substance from the surface is known as desorption. Desorption. Next, the curves obtained when graph is plotted between x by m versus pressure at constant temperature are known as adsorption isotherms. Isotherm means at constant temperature, graph between x by m versus pressure. Freundlich adsorption isotherm is x by m equal to k into p power 1 by n. So where x by m is amount of substance adsorbed per unit mass of adsorbent, k is constant, p is pressure of gas. So 1 by n is power. Next, so log x by m equal to log k plus 1 by n log p. So here slope is 1 by n and intercept is log k. Next, colloidal solutions. So colloidal solution is heterogeneous binary system, in which particle size is 1 millimicron to 1 micron, or we can say colloidal range, colloidal size 1 nanometer to 1000 nanometers. colloidal particle range. So while in case of true solution less than 1 nanometer, while in case of suspensions greater than 1000 nanometers. This is particle size. Next. So colloidal solution contains two parts, dispersed phase and dispersion medium. So dispersed phase are distributed in a continuous dispersion medium. So medium is similar to that of solvent, phase is similar to that of solute. Next, colloidal solutions are classified into lyophilic and lyophobic based on force of interaction between phase and medium. Next, the colloidal solution in which greater affinity exists between phase and medium are known as lyophilic. Philic means attraction. Next, see here, starch, protein, polymer solutions are examples for lyophilic. Colloidal solution in which there is little or no affinity exists between phase and medium are lyophobic solutions. Phobic. Next, here gold metal soles of metal sulfides and oxides are examples for lyophobic. Next, lyophilic colloids are reversible and lyophobic are irreversible. Lyophobic are irreversible. Next. So dispersed phase and dispersion medium in fog are liquid and air. Phase and medium in smoke are carbon particles and air. Phase and medium in milk are liquid fat and water. Phase and medium in cloud are water droplets and air. Next, phase and medium in blood are albuminoid particles and water. Albuminoid particles and water. Next, phase and medium in gold solar gold particles and water. Next, phase and medium in solid sols are, that means dispersion phase. If phase is liquid and the medium is solid, those solutions are known as gels. Cheese, butter, jellies examples. Rubber is obtained from latex by coagulation. Coagulation means nothing but similar to that of precipitation. Next, the potential difference between fixed layer and diffuse layer of opposite charges is known as electrokinetic potential or zeta potential. It can be positive or negative. Emulsions. A dispersion of finely divided liquid droplets in other liquid dispersion medium is known as emulsion. So emulsion is liquid in liquid type of emulsion, that means colloidal solutions. Emulsions are classified into two types, oil in water, water in oil. Next, oil in water type of emulsion, the dispersed phase is oil and medium is water. So vanishing cream is example for oil in water type of emulsion. Water in oil type of emulsion, dispersed phase is water and medium is oil. Next, the third substance which is to be added in small amounts to stabilize emulsion is known as emulsifier or emulsifying agent. Next, separation of an emulsion into two components is known as de-emulsification. De-emulsification. Separation of phase and medium. Next, catalysis. A catalyst is a substance that alters rate of reaction without undergoing any change in its composition at the end of the chemical reaction. Next, catalysis is of two types. homogeneous catalysis, heterogeneous catalysis. Next, if catalyst and reactants are in same phase, that is homogeneous catalysis. Example, all are gases. Next, catalyst and reactants are in different phases, that is heterogeneous catalysis. This is the example. Reactants, gases, catalyst is solid. Next, the substance which increases the activity of catalyst is known as promoter. In Haber's process, molybdenum acts as promoter and catalyst is iron. Very, very important. Next, the substance decreases activity of catalyst is known as catalyst poison. Catalyst poison. In Haber's process, for the manufacture of ammonia, carbon monoxide acts as catalyst poison for Fe. So, because Fe can form complex with CO, catalytic activity of iron will be destroyed due to the presence of carbon monoxide. Next. So, during a chemical reaction, if one of the products formed acts as catalyst, that phenomenon is known as autocatalysis or self-catalysis. That means in this reaction, AsH3 decomposes to As and H2. As acts as autocatalyst. No need to add external catalyst here. So one of the products can act as catalyst. Next, the process of converting a PPT into colloidal solution is known as peptidation. Peptidation. Next, the process of removing dissolved substances from colloidal solution using suitable membrane is known as dialysis. Dialysis means purification of colloidal solutions. Next, the phenomenon of scattering of light by colloidal size particles is known as Tyndall effect. Tyndall effect. Next, the zigzag motion of colloidal particles in dispersion medium is known as Brownian movement. So, Tyndall effect is optical property. Brownian movement is kinetic property of colloidal solutions. Adsorption always exothermic because during adsorption there is always decrease in residual forces of the surface. Next, zeolites are good shape selective catalysts because of their honeycomb structure. Next, movement of colloidal particles under applied EMF is known as electrophoresis. So, movement of colloidal particles either towards cathode or anode when an EMF is applied is known as electrophoresis. Next, the movement of colloidal particles is arrested by some suitable dispersion medium moves in opposite direction. Very, very important. This phenomenon is electroosmosis. Next, the phenomenon in which colloidal solution will be converted to PPT by the addition of suitable electrolyte is known as coagulation. Next, the minimum concentration of electrolyte required to cause coagulation is known as coagulation value or flocculation value. Flocculation value. Next, a lyophobic sol can be protected from coagulation by the addition of lyophilic colloid. So, this lyophilic sol added is known as protective colloid or protective agent. The mass in milligrams of protective colloid must be added to 10 ml of gold sol to prevent the coagulation by the addition of 1 ml of 10% NaCl solution is known as gold number. So, gelatin has very less value, therefore, it has maximum protecting power. Next, So this is very important. The cluster or aggregate particles formed by associated colloids are known as micelles. Next, a colloidal size particle formed in water by association of simple molecules, each having hydrophobic and hydrophilic end, is known as micelle. So micelles are having hydrophobic and hydrophilic end. These are associated to form large size particle, that is micelle. Next, see here, sodium stearate dissolves in water to form Na plus ions and stearate ions. So this sodium stearate behaves as normal electrolyte at normal concentration, but at higher concentration it behaves as associate colloids or micelles. So here it is having C17H35 hydrophobic end, next COO minus Na plus hydrophilic end. Next, the concentration at which micelles are formed is known as critical micellization concentration, CMC. So above this concentration, micellization takes place. The temperature at which micelles are formed is known as Kraft temperature. So minimum temperature is required for micelle formation. So greater the charge of ion, greater will be the coagulating power. So -4 will be most effective for coagulating positive sol. +3 is more effective for coagulating negative sol. So this is about synopsis. Next we will discuss worksheet questions. First question. 10 grams of gas is adsorbed on 500 grams of solid at 10 bar. If the pressure is increased at 20 bar, 14 grams of gas is adsorbed by the same solid at the same temperature. What is the slope of Freundlich adsorption isotherm? So according to isotherm, we can write x by m equal to k into p power 1 by n. So apply first condition. So x is mass, that means amount of adsorbate adsorbed per unit mass of adsorbent. K is constant, p pressure, 1 by n slope. That means we can write like this. First condition. So 10 grams adsorbed on 500. That is equal to, so K value constant. So pressure is 10 or 1 by n. Next, second case. So this is expression 1. Next, 14 grams on the same solid, 500 equal to K into, so pressure is 20 power 1 by n, which is expression 2. So here 2 by 1 gives, or 1 by 2 gives, expression 2 by expression 1 gives, so 14 by 10 equal to 2 power 1 by n. So therefore 1 by n equal to 0.485, which is approximately 0.5. Approximately 0.5. Option D. So here 1 by n is slope. Next question. So the coagulation of 200 ml of positive colloidal solution, 0.73 grams of HCl were added without changing the volume much. The flocculation value of HCl or coagulation value. So here for 200 ml of sol, 0.73 grams of HCl is required. So therefore millimoles of HCl equal to, so 0.73 by 36.5 So we'll get this value as 20 millimoles. So 20 millimoles from this. So therefore 200 gram, that means 200 ml of solution requires 20 millimoles of HCl. So therefore 1000 ml sol, that is 1 liter, requires say X millimoles. So therefore X can be 1000 into 20 by 200. So which is equal to 100 millimoles of HCl. So number of millimoles of electrolyte which is required for coagulation is known as coagulating value. So therefore 100 is coagulating value or flocculation value. So very important. Next. So catalysts in the following reactions are. So in first reaction, so CH3 COOCH3 plus H2O gives CH3COOH plus CH3OH. Hydrolysis of ester so takes place in the presence of acid. 2SO2 so plus O2. Say second equation, 1 second. 2SO2 gas gives 2SO3 gas in the presence of PT. Third, 2SO2 plus O2 gives 2SO3 takes place in the presence of NO, nitric oxide. Fourth, N2 plus 3H2 reversible with 2NH3. It takes place in the presence of iron. Therefore, in first case, H plus means you can write HCl, PT, NO and Fe. Option A. Corresponding catalysts. Next. So which of the following options are correct? See here, simple. So chemical adsorption, that means first option A. If we take graph A, this is graph A, write options here. A graph, B, C and D. See here, A graph represents chemical adsorption. Next, C graph represents again chemical adsorption. See here. So why A is chemical adsorption means chemical adsorption requires activation energy. Activation energy is needed. Very important. So as the temperature increases, amount of substance adsorbed also increases. So after activation energy reached, that becomes constant. Next, C is also. So during adsorption, potential energy decreases up to bond formation. After bond formation between adsorbate and adsorbent, again the potential energy increases with increase of distance. So therefore A and C represent chemical adsorption, that is option C. Next. The gold numbers of gelatin, hemoglobin and sodium acetate are given 5 into 10 power minus 3, 5 into 10 power minus 2, 7 into 10 power minus 1. Protective power. So as the gold number decreases, protective power increases. See, gold number is minimum for gelatin. So therefore, first one gelatin, after that hemoglobin, and at the last sodium acetate. So gold number and protective power are inversely proportional to each other. So option B. Next, identify correct statements. See, a closed vessel containing CO2 and O2 can form aerosol. That is incorrect. So it will form homogeneous mix. Therefore, it is not colloidal solution. So one is incorrect. Next, what about 2? Milk is emulsion. That is correct. Smoke is aerosol. That is also correct. Next, peptidization is the method of purification of colloidal solution. That is wrong. Peptidization is preparation of colloidal solution from PPT. So fourth wrong. Next, ultrafiltration is the method of purification of colloidal solution. That is correct. 2, 3, 5 are correct. Option. So this is just preparation. Peptidization means making. Conversion of PPT into colloidal solution. Therefore, 2, 3, 5 are correct. Next. If the value of 1 by n is equal to 1, in friendly chats option I saw the x by m. So we know x by m equal to k into p power 1 by n. So here 1 by n is given 1, therefore k into p. Since 1 by n, which is equal to slope equal to 1. So k into p, therefore option B. Next. The key step in manufacturing of H2SO4 by contact process is. So very important. Key step is 2SO2 gas plus O2 gas will be converted to 2SO3 gas. So this is key step. So a delta H value minus 196 kilojoules. So exothermic process. This is key step. Formation of SO3 is key step. Very important. So here best catalyst is V2O5 solid. Best catalyst. So D. Catalytical oxidation of SO2 with O2 to form SO3. That is key step. Next. Relatively, which condition favors faster Brownian movement of colloidal particles in solution? So movement will be rapid when size decreases. Smaller size and less viscosity. If viscosity increases, flow nature decreases. Therefore, less viscosity is required for movement. Smaller size particles will move randomly with higher velocities. Therefore, smaller size and lesser viscosity is required for Brownian movement. For faster Brownian movement. Next. The sol formed when As2O3 reacts with H2S. This is best example for double displacement or double decomposition. It gives As2S3 plus 3 moles of H2O and take here 3H2S. So As2S3 Sol. So this is best example negative Sol. Option B. That means negative colloidal solution. Next. The macromolecular colloids of the following are. So macromolecular means you can take polymers. So here polymers are starch. Starch is polymer. And synthetic rubber. Synthetic rubber. So these two are polymers or macromolecular. Therefore option D. Next. The diameters range of colloidal particles approximately. So colloidal size ranging from 1 nanometer to 1000 nanometers clearly. So therefore option A. 1 nanometer to 1000 nanometers colloidal range. Next. The adsorption of gas at boiling point of gas follows the isotherm shown in the figure. Identify correct thermodynamic properties. So at point C, so when pressure increases, amount of gas adsorbed remains constant. That means at point C, there is equilibrium. So with increase of pressure, there will be no change in amount of gas adsorbed. Therefore, process will be at equilibrium. So at equilibrium, so delta G becomes equal to 0. So we know delta G equal to delta H minus T delta S, which is equal to 0. So or we can write delta H equal to T delta S. This is the condition. So a delta should be there. Delta H equal to T delta S. And delta G is 0. Here all are deltas only. D is given. All are deltas. So very important. Delta G 0 means delta H becomes equal to T delta S. Delta should be there. So here delta. Delta H equal to T delta S and delta G equal to 0. Delta H greater than delta T delta S. Delta G is positive. Delta H, T delta S, delta G, delta H, T delta S, delta G. So here clearly option A delta H equal to T delta S and delta G is 0. Very important question. Delta. Option A clearly. So at point C there is no change in amount of gas adsorbed even after high pressure. Even pressure is increased. Therefore system will be at equilibrium. Next, plot of log x by m versus log p. log x by m versus log p. So here slope is given by, we know x by m equal to k into p power 1 by n. So log x by m equal to log k plus 1 by n into log p. It is in the form of y equal to c plus mx. Therefore slope equal to m, which is equal to 1 by n. Option C. And intercept is C. So C equal to log k. Remember this one also, log k. Next. So which of the following is not characteristic of chemical adsorption? So it is highly specific due to formation of chemical bond between adsorbate and adsorbent. Heat of adsorption is very high, 40 to 400 we can take, very high. This process is irreversible due to formation of bond. It forms multi-layers, that is wrong. So it forms unilayer or monolayer. Due to chemical bond formation, it forms only unilayer. So option D is incorrect. Next. So which of the following statement is correct for adsorption of solutes on solids in solutions? Here, extent of adsorption increases with increase in temperature. Extent of adsorption increases with an increase in temperature. Next. Extent of adsorption decreases with increase in surface area of adsorbent. That means adsorbate. Extent of adsorption decreases with increase in temperature. Extent of adsorption does not depend on amount of solute in solution. So here clearly correct statement is adsorption decreases with increase of temperature. So as the temperature increases, the force of attraction between adsorbate and adsorbent decreases. So therefore surface molecules will be escaped. Therefore option C is correct. So adsorption decreases with increase of temperature. So desorption takes place. Desorption takes place. Very, very important. Option C. Next. So which of the following statement is not correct? Not correct. So mixture of dinitrogen and dioxin forms aerosol. That is wrong because it forms homogeneous. Homogeneous mixtures are not colloidal solutions. Next, lyophilic salts are more stable when compared to lyophobic due to more force of attraction between phase and medium. Next, formation of micelles is possible only above craft temperature. That is correct statement. An example for soap is sodium stearate and example for detergent is sodium lauryl sulfate. That is also correct. So A is wrong. A is not correct. Because mixture of N2 and O2 can form homogeneous mixture. Homogeneous mixtures are not colloids. Next. So which of the following statements is not correct about chemisorption? It is highly specific. That is correct. Irreversible. That is also correct due to bond formation between adsorbate and adsorbent. Next, multi-layer. That is wrong. It forms unilayer or monolayer. That means option C is incorrect. High enthalpy of adsorption. That means you can take it as 40 to 400 kilojoules per mole, very high. That is also correct. Only C is incorrect. Next. So for Friendly adsorption, the slope and intercept respectively are. So x by m equal to k into p power 1 by n. So log x by m equal to 1 by n into log p plus log k. It is in the form of y equal to mx plus c, intercept form. Here slope equal to m equal to 1 by n and intercept equal to c equal to log k. So option B, slope and intercept. Next. So when FeCl3 is added to excess of hot water, it gives X. When FeCl3 is added to NaOH, it forms Y. X and Y. The FeCl3 with water gives Fe2O3 XH2O followed by adsorption of Fe3 plus ions at surface. Next, FeCl3 with alkaline solution NaOH forms Fe2O3 XH2O. So with adsorption of OH minus ions. So this is positive Sol and this will be negative Sol. This is X and this is Y. Therefore, option D. In basic medium, it can form negative Sol. So with aqueous medium, it forms positive Sol. Positive Sol is due to adsorption of Fe3 plus. Negative Sol is due to adsorption of OH minus. Next. So colloidal solution commonly used in treatment of skin disease. Skin disease. So colloidal sulfur can be used. Colloidal sulfur can be used due to its large surface area. Large surface area. So option C. Next. A colloidal solution is subjected to an electric field, then colloidal particles move towards anode. So moving towards anode means anode is positive charge, therefore solution is negative Sol. Therefore given Sol is negative Sol. Next, the amount of electrolytes BaCl2, AlCl3, NaCl required to coagulate will be in the order of coagulating value we have to find. So for coagulation, of negative Sol, comma, the power is, that means coagulating power. Coagulating power is in the order. So here AlCl3 power will be highest for Al3 plus, next Ba2 plus and Na plus. Therefore coagulating value is Al3 plus less than Ba2 plus and here greater and here less than. So coagulating power and coagulating value are inversely proportional to each other. Therefore, more amount of NaCl is required due to low amount of charge. So option A. So power inversely proportional to value. Very, very important. For coagulation of negative soul. Why it is negative soul means that is moving towards anode. Next. So critical micellization concentration is given CMC for soap is given 1.5 into 10 power minus 4 moles per liter. So micelle formation is possible only when the concentration of soap is. So micellization takes place when concentration increases CMC, then micelle formation takes place. Very, very important. So a CMC is given 1.5 into 10 power minus 4. Therefore, more than this concentration is required. So therefore, concentration must be 2 into 10 power minus 3 molar, which is more than CMC. When concentration is more than CMC, micelle formation takes place. Option A. Next. So hydrogenation of vegetable oils in the presence of finely divided nickel catalyst reaction is. So hydrogenation of vegetable oil. Vegetable oils are liquids. Hydrogenation means H2 gas in the presence of nickel solid gives saturated fat, which is known as vanaspati or dalda. Very, very important. Vanaspati or dalda. So this is also solid. Check here now. Reactants and catalysts are in different phases. Therefore, it is heterogeneous catalysis. Heterogeneous catalysis. So option C. So reactants and catalysts are in different phases. Next. So which of the following is not favorable condition for physical adsorption? So high temperature. So as the temperature increases, physical adsorption decreases. Therefore, high temperature is not a favorable condition. Next. So which are the following statements is incorrect with respect to physical adsorption? The forces involved are van der Waals forces, that is weak forces, that is correct. More easily liquefiable gases are adsorbed easily, so that is also correct. So under high pressure, it results into multi-layers on adsorbent surface. Next, delta H adsorption is low and positive. So here option D should be there. By option D means, one second, option D. So delta H of adsorption will be negative, but here positive is given, which is exothermic. So delta H of adsorption is low and negative, exothermic. But here positive is given, therefore D. D is incorrect. Enthalpy of adsorption is negative. That means amount of energy will be released and it is low. So 20 to 40 kilojoules per mole. Next, the electrolyte having maximum flocculate value for positive sol. Here it is given AgI in contact with Ag plus. So which is positive sol. So for coagulation of positive sol, negative ions are required. So here negative ions are S2 minus, PO4 3 minus. So which has maximum power. Power order is, that means coagulating power, PO4 3 minus. Next SO4 2 minus. So which is equal to almost S2 minus. After that Cl minus. Next, value, coagulating value order, PO4 3 minus, SO4 2 minus and S2 minus and Cl minus. So therefore, maximum amount of NaCl is required. So power and coagulating power and coagulating value are inversely proportional to each other. So power is maximum for 3 minus. Value is high for Cl minus. Therefore, more amount of NaCl is required. Maximum value. Value means here amount. Value order or amount order. More amount of NaCl is required due to minimum charge. Pick out false statement, incorrect statement. Colloidal solution of liquid is called gel. That is wrong. So liquid in liquid. Type of colloidal solution is known as emulsion. So A is clearly wrong. Next, hard disk rule is related with coagulation. Next, Brownian movement and Tyndall effect are shown by colloidal system. That is also correct. Gold number measure of protecting power. That means this is the gold number value decreases. Protective power of lyophilic sol increases. Remember this. Gold number and protective power inversely proportional. The adsorption graph is given, shown by here log x by m equal to 1 by n into log p plus log k. So here slope is m, which is equal to 1 by n. So that is y2 minus y1 by x2 minus x1, which is 2 by 3. So therefore x by m equal to k into p power 2 by 3. So p power 2 by 3, A is the option. So this is the end of the chapter. Next video I will explain one more chapter. All the best and thank you.